For right now, let's talk about special quadrilaterals. So I'm going to be talking about figures that have four sides. So I want to talk about polygons with four sides. So there's going to be 7 names we're going to be talking about: rhombus, rectangle, squared, kite, parallelogram, trapezoid, and isosceles trapezoid. Now for a rhombus, what it is a quadrilateral, so four sides, and all the sides are equal. So let me draw an image of a rhombus. Matter of fact, let me draw 2 of them. The interesting part of a rhombus, like I said, is that all the sides are equal. So I can tell you all the sides are equal if I mark them the same way. I don't know exactly how big they are. I just know they are all equal. I can either mark them with slashes, as you guys can see, or I can actually mark them with numbers. I can even use decimals, right? I mark them all with the same slash or the same number. So rhombus, what a rhombus is that all the sides have the same length. That's a rhombus. Now a rectangle is it's a quadrilateral that all the angles are equal. And in this case, I'm going to mark them with a little box. A little box represents 90. So I mark them all the same way. So they all have 90 degrees. All the angles are equal. That's what makes it a rectangle. A squared, what we're going to call this squared, it's a combination of both. It has to be a rhombus and it has to be a rectangle. So squared, it's a combination of both. So the way we look at a squared, it has to be a rectangle. So all the angles have to be equal. And it has to be a rhombus, so all the sides have to be equal. Once again, I can mark them. When it comes to sides, I can mark them with slashes, or I can actually give you an actual number. So rhombus, all the sides are equal. We don't care about the angles. Rectangle, all the angles are equal, not necessarily the sides, just the angles. Squared, it's a combination of a rhombus and a rectangle. So all the angles are equal and all the sides are equal. Now, when it comes to the kite almost looks like a rhombus. Almost looks like a rhombus. So let me draw a kite. I'll explain in a minute what's the difference between a rhombus and a kite. Now the kite, the two sides on the top are equal. Again, I can mark them with the slashes. Now the two sides at the bottom are also equal, but not all four. So the two on the top are equal, the two at the bottom are equal, but not all four. Once again, I can mark them with slashes, or I can actually give you numbers. I can say the top, I can do 5.3, 5.3, and I can call this 7.2, 7.2. Right, the two on the top are equal, the two at the bottom are equal, not all four. So that's what makes it a kite. For a parallelogram, parallel is very, very important in a parallelogram. What we deal with a parallelogram is the top side and the bottom side are going to be parallel. We talked about this in Algebra 1. Parallel means two sides that keep on going the same direction and they never intersect. So the way I'm going to show you they are parallel, I'm going to use arrows in this case. When I use slashes, that means the measurement is the same. When I use arrows, I'm telling you those two are parallel. I said in a parallelogram, parallel is very important. Now, the sides, the one on the left, the one on the right, the two sides are also going to be parallel to each other. And I'm going to use parallel once again with arrows. So I'm using little arrows right there. The top and bottom are parallel, the sides are parallel, and that's what gives me a parallelogram. Now, the cool thing on the sides as well, one interesting part on the sides is the top and the bottom are also equal. So I can say the top and the bottom have the same length, and the two at the sides are also equal. This is the interesting part of a parallelogram. Now, a trapezoid, the top and the bottom side are going to be parallel, but the sides are not. So only the top and the bottom are parallel. So I'm going to indicate with arrows. Top and bottom are parallel. If you notice, one of them is even smaller than the other. And then these two sides, the one on the left and the one on the right, are not parallel. Right? If I made them continue, they eventually cross, so they're not parallel. So that's what the trapezoid is. Top and bottom are parallel, and the two at the sides are not. Now we also have an isosceles trapezoid. Isosceles trapezoid obviously has to look like a trapezoid. Top and bottom are parallel, but the interesting part of the isosceles trapezoid is the sides have the same length. The one at the left and the one at the right. Those have the same length. If it is a trapezoid and the two sides, the one at the left and the one at the right, are equal, we call it isosceles trapezoid. Now, if those two are not equal, we just call it trapezoid. So you will be dealing with both names. Now, another interesting part in trapezoids when it comes to angles is that the two angles on the left must add up to 180. That's an example. I can call this 100 and I can call this 80. Those two angles have to add up to 180. The two angles on the right also have to add up to 180. So I can call this 120 and 60. Right? They do add up to 180. Now notice that the angles on the left, the numbers on the left and the numbers on the right, I didn't use the same numbers. I just said the numbers on the left have to add up to 180. The numbers on the right have to add up to 180. And they do. Now, if it is an isosceles trapezoid, once again, let me say the two angles on the left add up to 180. Now, the interesting part on the isosceles trapezoid is the numbers that I use on the left, I have to use the same numbers on the right. So I'm just going to say 180. If it is an isosceles trapezoid, the two numbers on the left are the same numbers from the two angles on the right. If it is just a trapezoid, not isosceles, just a trapezoid, the two angles on the left are not necessarily the two angles on the right. All right, let's take a look. State the most specific name for each figure. Because of the angles, I know it's a rectangle. Because of the sides, they all have the same length, I know it's a rhombus. A rectangle and a rhombus combined, I'm going to call this square. Now, question number 6, I know that all the sides are equal. Not necessarily the angles, just the sides. So I'm going to call this rhombus. Now, looking at number 7, all the angles are equal, but the sides are not. So this is what I call a rectangle. When it comes to question number 8, I notice these two numbers add up to 180. These two numbers add up to 180. And then also, these two sides are equal. If you twist it around, you're going to be able to see your isosceles trapezoid. Whenever you type in my homework, remember in your English classes, they tell you when you type in words, they call it sentence. When you write a sentence, capitalize the first letter of the first word. So the same thing here, capitalize the first letter of the first word. Notice how squared, rhombus, and rectangle, I capitalize the first letter. Now, when it comes to isosceles trapezoid, I only capitalize the I on isosceles, not the T on trapezoid. Only capitalize the first word, first letter. Okay, that's what we called special quadrilaterals.